In this video, we are going to talk about inverse trig functions. I suggest that you pause as needed so that you can read the words to make sure that you understand what is going on. But otherwise, let's do it. So for a function to have an inverse, it must be 1 to 1. Thus, the function must pass a horizontal line test. For functions that do not pass a horizontal line test, finding an inverse function requires making the function 1 to 1 by setting restrictions on the domain. If you think about the sine function is not 1 to 1 because different values of x yield the same y value. For example, if we draw or we do a little sketch of a sine graph, not a great sketch. You could see at this location, this location, this location, this location, all of those x values would produce the same y. That means that the graph is not a 1-to-1 graph. However, if we restrict the domain of our sine to negative pi over 2 and pi over 2, what we end up with is just this this area of the graph. And we're only talking about this little smidge right here from negative pi over 2 to pi over 2. And on that interval, we can see that the sine is increasing because it's going up from left to right. On that interval, we can see that the sine takes on its full range of values. The sine values are from negative 1 to 1, and that section covers them all. And you can also see on that range that the sine is a 1-to-1 function. Therefore, you can take the inverse of it. So here's our definition of an inverse function. The inverse sine function is defined by sine negative 1 of x, so that is the inverse sine, or by arc sine. So both of those mean the same thing. It's if and only if the sine of y equals x, where x is between negative 1 and 1, and y is between negative pi over 2 and pi over 2. So the domain of the inverse sine is negative 1 to 1, and the range is negative pi over 2 to pi over 2. Notice that those are the reverse of the domain and range for the sine function. All right, if you have to evaluate the inverse sine function, it helps to remember the phrase, the arcsine of x is the angle or number whose sine is x. So here we're going to try and find the exact values. Let's look at b first. So we're trying to find the inverse sine of root 3 over 2. What this means is that we're looking for the angle that when you take the sine of that angle, you get root 3 over 2. So we are looking for this, the sine of something that will equal root 3 over 2. So if you use your unit circle or you use your left-hand rule, when you figure out the sine of x is root 3 over 2, that occurs at 60 degrees or at pi over 3. Because pi over 3 is in this domain, then it is an answer. So we can just write down pi over 3. Let's go back to A now. On A, we want the arcsine of negative 1/2, or we want the inverse sine of negative 1/2. So we are looking for the value of an angle. We're looking for an angle that when we take the sine of it will give us negative 1/2. So again, you can use your unit circle or you can use your left-hand rule. If you use your left-hand rule, you will identify that pi over 6 is where the sine equals 1/2. But we need the sine to equal negative 1/2. So if we use this diagram again, pi over 6 is going to be, somewhere up here. But remember that these things are cyclical. They are cycles. So if we went in the negative direction, pi over 6, we would get negative 1/2. So that is our answer, negative pi over 6. Let's look at C. For C, we want the inverse sine of 2. But here we have to think for a second, what angle, when I take the sine of it, would give me 2? And the answer is that doesn't exist. Because the output for the sine is from negative 1 to 1. It doesn't go higher than 1. So therefore, this does not exist. And now, finally, for part D, we want the arcsine of 1/2. We actually kind of already came across this when we did part A, and we know that the inverse sine of 1/2 is going to be equal to pi over 6. Cool. You can also think of it like this. You're asking yourself what angle between negative pi over 2 and pi over 2 would give you that particular ratio, like 1/2. Okay, here are a couple extra examples. I suggest you pause the video and see if you can figure them out on your own. Okay, here are the answers to the additional examples. Go ahead and check them, and hopefully you did okay.